a good example of partnering with the Minnesota wheat growers. Dave Grafston is our next speaker, and David is a researcher at the University of Minnesota, and his research includes addressing P and K in wheat and soybean rotations. So welcome, David.
Thank you. Is this thing on? There it is. Perfect. Like I said, my name is Dave Grafstrom. I live in Roseau, Minnesota. And you might say, what in the world do you guys do in Roseau? I said, where is it? Well, take Highway 59, 75, 71, go as far as you can, and that's where we are. We're about 10 miles from the Canadian border. So on the way down yesterday, nice day, I was thinking, man, the thermometer in the car went from minus to plus. Get down here is about 20. The guy on the radio told me it's going to be 40 degrees today here. Well, last week, International Falls was minus 42 actual temp. Rose wasn't quite that much, but minus, that's a lot. So 40 today is going to seem like 60 for me on this neck of the woods. So appreciate the time. I'm going to talk about some work we've done in Roseau. If I can get this thing moving. Just what are we going to talk about today? A lot about what we know. We know quite a bit about the soils in Northwest Minnesota. Some basic soil laws of the minimum and maximum. That's something we don't think a lot about, but they do have application for what we do every day. The objectives of what we're doing, and then some 20 and 21 data. So what do we know? We know that glacial lake agassiz, and I'll talk more about that in a minute, was a major cause of the soils we have in a lot of Minnesota, but especially Northwest. Cold soils reduce nutrient uptake, and up where I live, we're got cold soils most of the year, it seems. A few times in June, July, and August is warm, but other than that, it's cold. High pH soils, Dan talked about that. We have high pH soils, and we'll talk about what we have. We know what this textbook tells us about nutrient removal. Just locally, for example, the beans that we raised probably 10 years ago, 7-30-30 is a pretty common mix of what guys used. The last few years, the local fertilizer plant tells me that in beans, guys are going 40, 50, even 60 units of each P and K, and they're seeing responses to that. So really what we're looking at here is the need that, well, if you're only putting on a 7-30-30, you got to expect a pretty good contribution from the soil. And that's kind of what we're looking at. So glacial lake agassiz. That's a big lake. Where I live, it's Lake of the Woods is a big lake, and it is. Look at the size of that lake. It was about 11,000 years ago. It's about the size of 5 states of North Dakota. That's big. Look at Northwest Minnesota, where I live. If this thing works, how do I do this? Lake of the Woods, that's a big lake. Lake Winnipeg, Lake Manitoba. But look at the size of that. That is huge. It's unbelievable. Now, on the way down, I drove 169, and I was just thinking about that Minnesota River Valley. That was carved by the glacial Lake Warren from the water that came from that Lake Agassiz. So we're seeing the impacts of Lake Agassiz down here. So anyway, though, what do we do? We have the lake bed soil, the lacustrine, with the heavy, fine textured soil, the stuff that sticks to your shoes. We have a lot of that. But then on the outwash plains and the beach ridges, we have kind of the coarser texture soils. We have both of those. What do we have in the soil? This was a survey from AgVi's laboratory in Northwood, North Dakota, just telling us that looking at Olsen P levels, it was after harvest. Back, in the northwest part of the state, 3/4 of the samples that were sent in were less than 15 parts per million Olsen. That's a lot. That's high. How about K? Not quite as bad, about 40%, but you get a little bit further east, it's about 3/4. So we know that we got soil, we have some challenges with what nutrients are in the soil itself. These two guys, we'll talk more about that. They're kind of godfathers, I guess, if you will, of soil science. A classic example of law of the minimum is Liebig's barrel. And the barrel stave concept states that, each one of those barrel staves is a nutrient, and your plant growth and yield will be limited by the most scarce nutrient. So the idea being there is to try to keep those barrel staves up as high as you can to maximize production. So in this case, it shows you low of P. Well, it doesn't matter how much N you put on, how much K you put on. If P is the limiting factor, limiting nutrient, that's what you're going to get. You're capped at that. So the idea is to try to make that barrel full. So the goal then is to provide nutrients, both micros and macros, that's going to maximize your yield, plant growth, and plant growth and yield. So the law of the maximum, it's Arthur Wallace talked about that, and he talked about over 70 growth factors that have an impact on plant growth and development. There's a whole long list of them there. I'm not going to go through them all, but this year in 2021, I'll talk more about that later. But it didn't matter what we did, management-wise, fertility-wise, weather, lack of water, capped our yields. Now, nothing we can do about that, but that's just the fact. Looking in the rearview mirror, we can see that, but we don't know that until we're into the. But it gets two things to keep in mind: the law of the minimum and the law of the maximum. Two very important principles in soil science. So the project I'm going to talk about today, the scope. Where is it? Well, it's USDA District 10, and it would be from here up to the Canadian border. Now, I live here, and that's kind of what we're looking at. It's 11 county area. In 2007, the soybean acres are 1.1 million acres in that geography. In 2017 was 1.8. Soybean yields, take a look at the difference in 10 years. It was flat. Didn't see any response of soybean yields. And why is that? Well, we're trying to say, well, maybe it's fertility. Wheat, on the other hand, from 2007 was 50 bushel average, 65 in 10 years. Now, there's no doubt that soybeans in the wheat rotation makes wheat better. There's absolutely no doubt about it. You get the N credit, you get better weed control. Wild oats is one of our problem weeds in wheat. That's taken care of very nicely with some of the products we have in soybeans. So those are things that we're looking at. So we're trying to say, well, let's see if fertility was a problem or the issue. So that's kind of the reason why we're really looking at this research. The trial we're talking about really incorporated both small plots and large plots. So small plot research, what we try to do is go out and find a nice uniform piece of ground, impose some treatments, baby them, do the best we can, kind of put up a kind of best possible scenario. In field, we have variation from side to side, end to end. That's just how it is. That's just the fact of the matter. So in the large plots, we want to try to manage that variability that we've never had. So it's kind of two different concepts, but they are complementary. The objective is to establish a long-term rotation, 4-year minimum of wheat and soybeans. So we're both conducting small plot and large plot trials. And the partnerships here, I can't say enough about what this, it took a while to get here, but really the AFRAC organization, Minnesota Wheat, Minnesota Soybeans, University of Minnesota, and the grower cooperators. And the grower cooperators were just fantastic that we've worked with. And they haven't kicked us off yet. Hopefully they don't, but they let us do what we need to do on their farms. Some of the specifics talked about that. We're managing for an 80 bushel wheat and a 50 bushel beans, which is high, but it's attainable. In the small plots, it's a small plot randomized complete block design with 4 reps. We're using tissue soil. We're collecting soil samples after harvest and tissue samples in season, and collecting a certain amount of data. Now, 2020, Remember back then? This graph will tell you that's from end on, it's North Dakota Ag Weather Network. The blue line is normal or average. Below that is colder than normal. Above that is higher than normal. Look at that, you can see, well, there's a lot more above the line than below, so 2020 was warmer than average. The rainfall, the light bar is average, the dark bar is 2020. June, July, double the rainfall. So to summarize 2020, for us, we were warmer than average, we were wetter than average. 2021, we just don't see 100 degrees in Roseville. Very rare to see 100. We said it a couple times last year. Again, the same end-on graph. The blue line is average. You can see there's a lot more above that blue line than below. And you look close, some of those are 15, 20, 25 degrees above average. It was dry. A lot of the soil we have is silt loams, a lot of clay, cracking, got this the shrink swell characteristic. We saw a lot of that. 2020, 2021, the rainfall, again, the light bar, average, dark bar, 2021. You can see that May, June, July, we were well below what we'd like to see. The Palmer Drought Index is kind of a way to that people talk about that. Looking at mid-July, there's a little bit of red, but end of August, there's a lot of that burnt orange, which is extreme drought. So just kind of let you know that we're in the dry side. Small replicated work was done at the U of M Magnuson Research Farm. Nancy Elke at St. Paul is the PI of the project. Just a picture of an aerial view of the Magnuson farm. That's where I work in the summertime. It's a 40-acre research site in Roseau. Pretty typical small plot work we do there. A lot of the locals refer to it as the grass seed farm because you do raise a lot of cool season grasses, Kentucky bluegrass, perennial ryegrass, timothy's, as we raise. A lot of the guys have historically done that. So that's where we do the work. I would say that the farmer cooperators that we use, a lot of them are around the Magnuson farm, and they are very, very helpful on what we do. I just can't say enough about the cooperation we have with the local farmers. The sites, we had the small plots, we had 2 sites each year, one wheat, one soybean, 15 treatments, and an untreated for a total of 16. The rates we use, well, the P source is 0.460, didn't want to have any impact of the N from DAP or MAP, so we went with 0.46. K source is 0.060. We use the actual P and K rates of 20, 40, 60, 80, and 100 separately and combined. And all those were spring applied prior to planting and then incorporated. Soil samples are being taken at 2 depths at the beginning and at the end. In the 2 years, used 2 and 3. We just did a 0 to 6 inch sample looking at P and K. In the year 4, which will be next year, we'll take a complete soil analysis to really see if there's any interaction with some of these elevated levels of P and K that we're applying, just to see if we have any impact on antagonism of other nutrients. And phosphorus and zinc is one that we have some concern about, and potassium and calcium. So specific, some of the trials, like I said, a wheat trial and a soybean trial, the nitrogen we used, it was 160 pounds of product was put on. That's our base rate. The 6x15 was our plot size. Linkert wheat was seeded at 120 pounds. And in beans, we had a 1.4 units, 172,000 final plant population is what we targeted. Some tissue tests were taken, and I think the harvest date on wheat, 7/31 this year, that's early for us. And beans, 9/13 is very early. So we've seen early harvest this year. So the background soil test, both soils are a silt loam, finer texture. Organic matter, 2.8% was the same. pH 8.2 at one site, 7.8, so it's high pH. The big difference is the Olson test on P. One site was 6 parts per million to start with. The other one was 23. And we did it on purpose just to get a spread on what we could do with these different rates. I guess all I want to say about that. Just a few quick slides to show you what things look like. Pretty typical small plot stuff in wheat and beans. Individual plots were measured out and then spread by hand. And then after we applied the fertility, we worked it in and then planted. Just got to give you a feel what the late season soybean trial looked like. And then use small plot equipment to harvest, and that's what we did. After harvest, took soil samples, and I guess the ag vice people tell us that there's no problem using WD-40 to make that soil probe work in our sticky soil. We use a lot of it, and they say that it doesn't impact any results. Without that WD-40, we'd have just a terrible time trying to get that soil to take samples. And with that, sometimes we got to use that WD-40 every 2 or 3 cores just to make sure that works. So in each plot, then we took about 8 cores and then submitted that for analysis. The results, it's hard to see, but this will be available for you to look at your leisure. But on the very left side, it's the treatments from 1 to 16. 1 to 5 is P alone. 6 to 10 is K alone, and then the combinations. So we're looking at bushels per acre, test weight, protein, soil test results P and K, and tissue tests. So there'll be 4 tables like this. It'll be the same. It's hard to read, but hopefully you can look at that at your leisure. So the yield range in 2020 wheat. Remember, 2020 was a warmer and wetter than average. 67 to 76 bushels per acre. That's what the yields were. And that's 76 is good for us in wheat. We did see a yield response from P rates to 40, 60, 80, and 100 of the combinations versus the untreated. So we were seeing, I should point out that in this case, the LSD was 7, CV was 7. So a CV is 7 for field work, that's gives you some level of confidence in the results are pretty tight. So we feel pretty good about the results. K alone, flat response. Didn't see any response at all with K in 2020. No difference in test weight or protein. We did see an increase in P with the soil test at the higher rates, 68 and 100. And the K rates in the tissue test, all rates tended to show an increase. Soybeans, same set of data, same setup. Again, we saw yields range 61, which is very good yields for us. 61 to almost 70 bushels. I mean, we're very happy with those kind of yields. Again, we saw a positive response from the combination of 20, 40, 60, and 80 of P and K over and above the untreated. No difference in test weight and protein. And the P applied alone, we saw an increase in the soil P levels in parts per million. Tissue test didn't see a lot of impact in 2020. 2021, again, the same setup. In wheat, the yield ranged from 60 to 84 or 85. 85 is very good for us. In a dry year, we think, how can we get that much? But remember, we had heavy soil. Wheat comes off a bit early, so we had good yields. And in the dry year, even though guys use fungicides, we do see better wheat yields in a dry yield because we got less disease. that we've seen it over and over again, and that was the case this year. So what do we see? Again, in this case, this is a low, even the low rate of 20 pounds of P2O5, we saw, over a 12 bushel increase in yield, and the other ones were over close to 20. So a very good response to P in this trial. Now I will point out that here the P level in the untreated is 3.7, so we're low. So Dan talked about that, though. You kind of see response when you have lower P levels, and we saw this in this case. So the K yields were similar, didn't see a lot of response there. Again, we saw responses of, if you add more P, you saw more in the soil test, which makes sense. Soybeans in 2021, 2020 was warm and dry. Our yields were not horrible, but they're in the 46 to 54 bushel range. Not near as high as they were in the year prior. And we just ran out of water. Upper beans were, instead of 3 beans per pod, or maybe 1. And we saw that in this case. So didn't see a lot of differences in yield, and we saw a little bit of difference in the soil test levels, but I guess I'll just suffice to say that was the dry year, and we do have those every time and again. Here, just to give you a snapshot, probably a little easier to say, in the yields per bushel in 2020 and 2021. The one in 2020, the light bar would be none, nothing applied. The dark bar would be P and K, the average P and K. So you can see that, there's a good response to both soybeans and wheat in 2020. In 2021, so the dry year, soybeans not so much, it's pretty flat, but we saw a fantastic response in wheat. So, Dan talked about the corn versus soybeans. We're kind of seeing the same thing with wheat versus soybeans, I think. Okay, go one more. So this kind of gives you we take soil tests after every year, just kind of give you an idea of what the soil test levels were post-harvest. So looking at here, this was taken in the spring prior to the first year, and this is fall, and these were fall. So in the low P site was 4, 3.3, 3.7. So we're seeing a decline, as you'd expect. In the high testing site, started with 17.5 in the fall, 16, 12.5, you got one more year. So we're going to see how far that comes down in after another year's growth. Maybe a little bit better to see this way. This is parts per million here versus the rate of 20P alone, 20K alone in the combinations. So that's just telling us in the low testing soil, which is not a surprise, the dark bar is 2019, the light bar is 2021. We're seeing it takes about up to 80 to build P alone. You don't put any P on in K alone, you're about like the untreated. And if you're seeing a little better response, and don't have a reason why that is, but with the P and K in this part of the graph, we're building quicker and much higher with the P and K level versus P alone. I have no reason why to say that, but you can see this is P alone, and that's a P and K. Got one more year to sort through that. The high P soil, not a lot of change there, but you can see the light bar with K alone in the middle. You don't put any on. We're kind of mining the soil, and that's what we're doing. Here we're putting on a little bit more. We're seeing a little bit of spike, but it's messy. It's not near as clear cut as the low testing soil. How are we doing on time? Good. Potassium levels, same kind of setup. Didn't really see any difference at all in the low testing soil or the high testing soil. Now, I know some of the guys talking about, well, there's kind of a challenge with potassium in 2-to-1 clay soils. I think that's part of what we're seeing. And there's, I know Dave Franz at NDSU, we'll probably hear more about that in the speaker coming up after myself. But there's some challenges with the types of clay and then how that impacts potassium availability. Because you think, man, you put on 100 units of actual K 3 years in a row and you can't move the needle? That doesn't make a lot of sense. But that's kind of what we're telling us. That's kind of what it's showing us. So that's the small plot. The large plot, it was just really kind of a fun part of the project for me to go and talk to farmers, go out to their field, see what some of their concerns are. So looking at the on-farm results, really looking at what happens in the real world. In the small plot work, guys say, yeah, you guys do this small plot work and you do all this kind of stuff and you put these little garden plots together and you do all this stuff. What happens in the real world where I'm at? Well, that's kind of what we're going to try to find out. So the research team, Missy Carlson with U of Minnesota Wheat was very important in this project. And then Don Velix and the U of M, myself, and summer interns to try to get this project done. The design was a strip trial, and generally the strips were either 70, which is the width of a interrogator, ideally 140, 2 passes. It's kind of the design. So looking at here would be, that'd be like a farmer practice, and that's whatever rate the farmer decides to use for P and K. That's what we call a farmer practice. So whatever rate that the grower says, that's the rate I want, that's the farmer practice. And then the farmer practice plus 50 was the 50 additional units of P and K that were put on. So in this case, here we got, a farmer practice plus 50, farmer practice. So we tried to get at least 4 reps across the field. That's kind of the design that we tried to go with. So in this case, we had 3 sites in Roseau County, 1 in Lake of the Woods, and then 1 in Grant County. And again, the farmer practice was the rate that the farmer chose. So we didn't try to argue about what kind of rate you want to put on, just whatever he was doing, or she. And that's what we used for that rate. And then we'll say, let's just put 50 of each P and K and see what the difference is, if any. So we use field scale equipment on all this trial. Irrigators applied the fertilizer. In our part of the world, we just love air seeders. We use air seeders all the time. So in wheat and beans, we seeded both air seeders. So we got narrow rows. At harvest time, the headlands are cut off first. And then each trip, it's really important that we got a full combine header width going down each strip. Then each strip was weighed and with the grain cart. The grain carts, the old weigh wagons were good. These grain carts with scales are much better. Really make that work nice for us. The challenge we have is taking the subsample, but we still got to climb in there and get a subsample from each strip. But again, the full header width that we want, and use a grain scale with a grain cart with a scale to measure each strip. I use the John Deere Gator for soil sampling. Works really well to go up and down the strip and take soil samples. This 2021, it's kind of interesting. Up where I live, a lot of the roads go north, south, east, west. But you look at the soils, and see a lot of streaks in the soils that go to the north and the west. And it must do with when the Lake Agassiz was doing what it did years ago. So you can see these strips of their kind of lighter textured soil within the heavy soil. And it's pretty common to see this in dry years. And this is not common, but we saw a lot this year. Can you see what that says there? 26 inches. Now you drop a crescent wrench in there, I don't think you could get it. I know you could. I mean, that's just kind of the shrink swell we have in some of our clay soils. So in 2020, what did we find out? Well, we had 1 wheat and 4 soybean sites. The wheat site really was confounded by herbicide drift, so we really don't have a lot of confidence in that site. The farmer practice plus 50 at one site produced higher yields than the rest. The tissue test we took, generally the farmer practice plus 50 was higher in P and K. And the fall soil test told us that we were building a little bit more nutrient than compared to what the farmer was doing, which is a surprise. The soybean yields range from 30 to 50. This is farmer level. And we had a little bit more in small plots, but that's still for us respectable. When you get 50 bushel beans, most guys have a smile on their face up where I live. 1 in 4 sites, 25% of the time, we saw a response from the additional P and K. So over the farmer practice, we're seeing 25% of the time that we saw a response. The interesting thing was across the field was 29 to 50 to 55, the strips. But the yield monitor, if you guys had them, to me, that was the most interesting part of the whole thing. And you guys probably know what I'm talking about, but went from 10 to over 80 in beans, 80. For us, that's fantastic. So within that strip, we were seeing that much variability. I'm not sure if that's good, bad, or otherwise, but that's what it was. So we're seeing a tremendous variability in the fields. So 2021, we had 4 wheat and 1 soybean. It's the opposite. Had moderate to severe drought in all locations. The wheat yields ranged from 42 to 79. Again, 25% of the time we saw an advantage from the additional P and K versus what the farmer was doing. In the soybeans, there was really no difference. There was only 1 site, small data set. We're doing on time. Okay, I better run. 2021, one of the sites had 25%. It's kind of the same as the year before. We'll see what happens this coming year, but that's kind of what this is telling us. But the combined analysis of all 4 sites really was no difference, but in 1 site there was. A little bit on economics. We all know that prices vary from year to year. This is just telling us in Roseau, the light bar is soybeans, the dark bar is wheat. That's kind of the price we had. Price of fertilizer, I know that goes up now. This only goes to 2021. I'm not sure, I didn't do the 2022, but this is probably going to go above here. We'll be up here somewhere. We all know it's going to be high. So just kind of, what does that, just take a price of the quantity, price of the fertilizer. What's it need to break even? Here's telling us soybeans, about 4 bushels in 2019, wheat, about a little over 8. Over here, that's what's going to take us to break even. So we're kind of really crawling before we walk in this economic stuff. But that's important that we do that. But that's kind of what we're doing. This will be one of the last slides. This slide tells you the fertilizer price versus wheat return in 2021. So looking at that's the 20p alone. Here's the high rate of both. This dark bar is the cost. The light bar is the return. This is wheat. You can see as you increase, here you get a pretty good response. Not much here because there's lacking P. Over here, pretty good response. So we're seeing, we'll do more of these as we get into this project more, but that's really what the farmers want to know. Am I making money? I'll put on more if I can have a good idea that I'm going to make more. So I think I'll just skip that and go to questions. How about that? So questions or comments or discussion, you want to talk hockey, I can do that. In Rosa, we have Polaris snowmobiles. They make Polaris, if you want to talk snowmobile, we can do that. I'll leave my contact information here if, and then these two websites, the wheat growers will have a summary of what we did, as will the University of Minnesota on their turfgrass website. So all this information I presented, if you have an interest, search those two websites and you can get further information. Or call or email me, either one. Questions?
Any questions for David?
Very good. Well, thanks for your attention. Oh. What maturity of beans? We're in the 00 to 05 bean range. We're up way where it's, and a few years ago we tried to raise beans that were too long, and we got Jack Frost came and hit us pretty hard. And that's a concern we have. We have a lot of, in our way, the frost typically would be second week of September. This past year, we didn't get a frost till third week of October. But generally, you start pushing that maturity, and even though the average is the second week of September, we could get some in end of August. So that's the challenge we have with. But on the positive side, we have a lot of daylight. In the summer, it's light at 4:30 in the morning, and it doesn't get dark till 10:30, 11 o'clock at night. So we have a lot of daylight to make up for that short growing season.
You have a question?
Yes, sir. The question is, you see the variability in fields, and I talked about 10 bushels to 50. In the small plots, we kind of get that taken care of. We go to the garden style, and we don't have that variability. We don't do a lot of on-farm work, to be honest, to be fair about it. We're just kind of dipping our toe into this, but what you say is exactly right. One of the guys I work with, he said, I don't like this 50, I don't like this 10 bushels. Why is that only 10? I like the 50. So, is it soil type? Is it moisture? What is causing that? And, we're doing a little bit of work with that, but I think you hit the nail on the head. We need to know more of that information. And that's what these large on-farm strip trials do for us. Will allow us to say, go through we did a little bit of this year. Going forward, we're going to go through the field, put a flag. Okay, you see a sweet spot. Why is that good? The bad for you see, we stubbed our toe here. Why did we do that? So I think what you say is right on target. Why that is, we don't know. But the more of these are on-farm trials that we do in a control setting, I think can provide some answers to that.
Okay. Thank you, David. Let's thank him.